Hey, good afternoon, everyone. Welcome back to my Wednesday lunch break series. My name is Doc V. I'm a meteorologist and meteorological scientist at the Weather Company, which is IBM. However, as you guys know, the views of this stream does not reflect those of my employer, but are just meant for educational purposes. They're pretty much here for me to kind of talk about the weather and to communicate information to you guys and educate. That's the whole goal here, to be able to kind of show some weather information off and be able to inform you guys to make the best possible decisions that you guys can make, as well as learn about some pretty cool and nerdy tropical meteorology things. So thanks everyone for joining the stream today. I appreciate you guys. We are tracking a hurricane, which was Major Hurricane Delta. We've already made it to the Greek alphabet. I just can't believe how active the season has been. 25 named storms so far, 9 hurricanes, and obviously Delta, which was a Category 4 hurricane with sustained winds of 140 miles per hour yesterday, was our third major hurricane of the season. So it's been a very active and busy season, guys, and that has continued here with Hurricane Delta, which is currently over land. It made landfall over the Yucatan Peninsula around 6:30 a.m. Eastern Time as a Category 2 hurricane with sustained winds of 110 miles per hour. So there has been some impacts there. I'll show you some of videos of what the folks were shown on Twitter. Some of the storm chasers, Josh Morgan, and some others out there that had some good shots out there. So let me share my screen and we will kick this off here. So let's take a look here at the current satellite image here of Hurricane Delta. So this is the infrared channel here. Wherever you see like these red, black, and maybe even some of that white shading there, that's essentially cold cloud tops. You can think of that as deep convection. And we saw a very deep shield of convection or overcast clouds. I think we call this a CCC in the Dvorak classification. But we've seen this quite big signature here in deep clouds. And this moved onshore about 6:30 a.m. and it's currently over the northeastern tip of the Yucatan Peninsula. There has been some recent developments over the last few hours here where we're seeing some fairly deep convective towers over the northern tip here in recent hours, and we've actually seen somewhat of a clearing in warming of brightness temperatures right on the northern coast there of the Yucatan, and it almost appears here as potentially we're starting to see somewhat of a larger eye emerge here with this storm as it moves out over the warmer ocean waters of the southern Gulf of Mexico. Now, if you guys were following this storm over the last 24 hours, the eye of this storm was extremely small. It was about 4 nautical miles in diameter. So, if we talk about record small eyes, I believe Hurricane Wilma had the smallest eye on record with 2 nautical miles, which was extremely small. And typically, when you get these very small eyes in hurricanes, those are the storms that can actually fluctuate the most in intensity. And that's because when you get these really small eyes, due to the conservation of angular momentum, those are the ones that can spin up very quickly. You can think of it as like one of those ice skaters that brings their arms over their head like a pirouette, and those are the ones that really spin up quickly. Same thing with a hurricane here. But when you have these smaller eyes as well, you can see these storms also weaken quite quickly as well. And that's what we saw before landfall here with this storm as it pushed into the northeast tip of the Yucatan. We were looking at a Category 4, 140 mile per hour sustained winds out over the ocean as there was over an area of very high ocean heat content and low wind shear. But then wind shear started to pick up right before it made landfall. It was pretty much more mid-level wind shear. And we saw the CCC feature emerge in the infrared channel, and that's where we saw the storm start to weaken. And we saw that weaken about anywhere like about 30 miles per hour before landfall. So now we're watching this storm. It's moving off the tip of the Yucatan, and we are expecting the storm to move over a more favorable environment again for re-intensification in the next 24 to 48 hours. I have the National Hurricane Center website up here. If you guys need any information on your life and property, the National Hurricane Center is the place to go to. Those are the experts here in with regards to monitoring these hurricanes to protect your life as well as your property here. But take a look at Hurricane Delta, currently positioned over the Yucatan Peninsula. Winds are at 105-mile-per-hour sustained winds. Central pressure has gone up in recent hours. It's up to 975 millibars. I think the lowest I saw was about 957 millibars. I know it was rapid. When it was rapidly intensifying, it was anywhere from 4 to 7 millibars per hour, which is quite insane. Actually, a fun fact here: Delta was the fastest storm on record to go from a tropical depression to a Category 4 major hurricane, and I think it took under 40 hours just to get to just to accomplish that feat, which it broke records from that with the previous storm, which it's actually losing my mind here what storm it was, but I'll have to check my Twitter feed to confirm what the name of that storm was. But anyway, we're checking out the storm here. The National Hurricane Center does have this tracking northwestward at around 17 miles per hour. Let's take a look at the latest track forecast here from the National Hurricane Center. And here it is. The National Hurricane Center does predict this will move out over the Gulf of Mexico here and re-intensify back into a major hurricane. The latest forecast update does bring this back to 120 mile per hour storm within 48 hours here, which means within 24 hours here. Thursday morning, it brings back to a major hurricane. And as it tracks more northerly here Thursday night into Friday morning, this is where we're going to have to pay attention for a possible Louisiana coast landfall. The folks who have lived out in Louisiana, I am so sorry. I can't believe there's yet another hurricane bearing down. I think this is at least the fourth time evacuation for some of the folks out in western central Louisiana. So it's been quite an active season, and it's pretty rare that we haven't seen Florida at all get into the action, which is good for Florida. But we've seen a lot of these central Gulf storms, which has been just causing havoc out there for the Louisiana coast. And this looks to be yet another storm to threaten the Louisiana coast. Right now, the most likely landfall point is somewhere across western central Louisiana, which is sparsely populated. There's a lot of bayous out there, but most of the Louisiana coast is under a hurricane watch at this point. And we do see tropical storm watches that have been posted for the Galveston Bay, Texas region, as well as the New Orleans area. So there is likely going to be impacts for much of the Louisiana coast here. And we can see by between Friday morning and Friday afternoon, the National Hurricane Center does predict this storm, Hurricane Delta, which will be a major hurricane at that point, could make landfall somewhere across the western central Louisiana coast border, and then track inland over the weekend. Saturday will likely move across northeastern Louisiana into western Mississippi, and then it will likely move into the Tennessee Valley and later into the Ohio Valley as a tropical depression Sunday into Monday morning. So, the good news about this storm, if there is any good news, is it's pretty quick moving. So the forward progression is expected to continue at a somewhat moderate pace as it moves inland, and that typically means that we having historical rains like over 20 to 30 inches is less likely with this storm, though we are expecting still flooding rains anywhere from 7 to even localized spots of 12 inches of rain, depending on the precise track of this. Inside of Louisiana and western Mississippi. It's still possible here. So we are still expecting flooding rains there. So let's take a look at Josh Morgan's. He's a hurricane chaser, one of the more famous ones. I think he's known as the Hurricane Man. He had his own channel here or show. He has been did move down to I'm sorry. He took a flight down to Cancun and chase this particular hurricane, and he has some footage here. I'll bring this up here so you guys can see just some strong winds and sideways driven rain. Josh just gets some really great shots here and does these live updates. So one of the best follows you can get on Twitter at iCyclone to see how some of these impacts of these hurricanes are during landfall. And you can see how this one was quite intense as well. There was a number of structural damages and trees down, but luckily this did degenerate into a Category 2 from a Category 4 right before landfall. So impacts were still significant, but they weren't as bad as what they could have been if we saw that Category 4 hurricane maintain its structure. Okay, so let me stop this video because I hear the winds in my background. So, okay, here we go. So, IBM, the weather company, have been developing a high resolution model, which is known as GRAPH. And this is a MPAS based model. And I wanted to show off the latest 12Z initialization of how the model is predicting Hurricane Delta to re-intensify and actually re-intensify and look quite impressive on satellite as it moves into the Louisiana coastline. And the one caveat I want to talk about this storm, actually this model, the MPAS model, is that when it's trying to resolve these hurricanes, it often has a tendency to overpredict the size of the eye of the storm. And we're seeing that bias in the model today. You can see how this model is showing a unrealistically large eye as it tracks across the northern half of the Gulf of Mexico and moves landfall into the Louisiana coast. But this is a nice example here of a re-intensifying hurricane prediction and a possible landfall somewhere across the western central Louisiana border. Now I want to show the wind field of this prediction model. So I'm going to click on the wind field here and let the images populate. And the one thing that I want to point out here is this particular storm, the eye was very small. It was 4 nautical miles at one point. And then it tracked inland across the Yucatan Peninsula. And then as the storm is predicted to move back out over the western central Gulf of Mexico basin, the wind field is predicted to expand. And you can see how the yellows and the greens are actually growing with time. And even the red shading and the whites there, those are the most intense winds near the core of the hurricane. You can see how those are expanding as well. And we're seeing a transformation in the models of this storm from what was a very small, intense, but small, dense cyclone core to a much more expansive core and potentially a much larger eye. And this suggests a couple of things. The first thing is essentially that when we get these bigger cyclones, these bigger cores, it's a little bit more difficult for these rapid intensifications or even very fast decays. So these bigger cores are a bit more stable in nature compared to these smaller eyes and these smaller cores. When you actually get a larger eye, it suggests that the wind field is going to be more expanded, and that typically can result in more impactful storm surge. As you get, you can think about these circulations around the core of the storm. Typically, on the eastern flank of the hurricane is where the location where winds are more southerly in nature. So as the storm pushes closer to the Louisiana border here and the coastline, you can see how the wind field continues to expand. Let me back it out a couple frames here. But we're going to have to deal with storm surge pretty much across much of central eastern Louisiana and even into parts of the New Orleans region. And that's where the onshore flow from the hurricane, the eastern quadrant, is always the most dangerous. The northeastern quadrant is always the most dangerous for storm surge. And that's where particularly these models are indicating where that storm surge could be most dramatic. The National Hurricane Center, let me go back to the National Hurricane Center and show out, they do have a new peak storm surge forecast graphic that has just been released this morning. And we're looking at the peak storm surge forecast here for the Louisiana coast and as well as eastern Texas here. And you can see here in the Galveston Bay, it looks like storm surge could be anywhere from 1 to 4 feet in nature. But as you go closer to the storm and actually get on the eastern side of the predicted track here, that's where we're seeing the most intense storm surge, where it looks like in the Vermilion Bay, in locations just east of that, in the bayous down there, that's where we're seeing potentially 7 to 11 feet of predicted storm surge. And then as you get into the peninsula of New Orleans here and the New Orleans region, that's where we could see anywhere from 4 to 6 feet of storm surge. So this essentially could be another LoRa type of repeat where the most significant storm surge is currently predicted to be away from the major population centers, which is good news for the folks living in the Louisiana coastal region there. But still, there's going to be some storm surge here. And the one thing that I want to point out here as well is if we take a look at essentially this experimental product from the Sarah page here, we're looking at essentially maximum water height above its normal peak, heights here. We are seeing possible river flooding scenarios set up here. Anywhere where you see these like oranges, reds, and dark red maroon shading, that's essentially where you could potentially see some river flooding with this hurricane landfall. And we are seeing essentially the I'm going to butcher this, the Atchafalaya River, which I apologize if I really killed that announcing there. That river could potentially see some significant flooding as this storm moves inland, as well as the lower Mississippi Valley, or the Mississippi River, excuse me, which could go into the southern Baton Rouge area. So that's another area where we could see some significant river flooding as this storm begins to move onshore. So those are some indirect impacts that we typically don't think about during landfalling hurricanes, but this is something that we're going to have to pay attention for, as well as the folks residing in Baton Rouge. Pay attention here, guys. Friday into Saturday, this is where we could really see those riverbeds starting to flood in. So just be careful if you're residing along any of those banks here of the lower Mississippi River into the Baton Rouge area. That's where we could start to see some problems as this hurricane begins to move onshore and generate some impacts. Now, I want to bring up, where is it here? I have a link. I'm going to have to, I thought I had this up here, but I want to bring it up and show you some of the state of the ocean here. Bring up the Physical Oceanography Division website and talk about tropical cyclone heat potential. Okay, so essentially what we're looking at here is essentially where the ocean is conducive for intensification of a hurricane. Okay, wherever you see like the orange, red, and pink, and even white shading, the white shading is actually exceptional. But this is where the ocean is in a state to essentially allow the hurricane to extract energy from the ocean. And we call this high ocean heat potential. And these are in units of joules per centimeter squared and kilojoules per centimeter squared. And wherever you see like the 140s, that's like a really prime region for intensification. And we're seeing that when the hurricane was moving, Delta was moving across this area here, this is where the hurricane was rapidly intensifying. And hey, so Kmart, I appreciate the enunciation of the pronunciation of that river, Atchafalaya. I hope I got that right. But that's the one river that, including as well as the Mississippi River, that we're going to have to pay attention to for some river flooding. But so as the hurricane moved over this Western Caribbean region here, this is where the hurricane rapidly intensified. We saw that Category 4 hurricane right in this area here, but then as some mid-level wind shear was imposed on the storm, we did see it weaken as it moved into the Yucatan Peninsula. Now, as it moves out over the southern half of the Gulf of Mexico here, we don't see as favorable environment as the Western Caribbean, but we are still seeing an ocean that is somewhat conducive for intensification. And this is where the National Hurricane Center is bringing the intensity of Hurricane Delta back to a Category 3 major hurricane with sustained winds of 120 miles per hour. We're expecting that to happen here in the coming 24 hours or so. However, the one breath of good news is that as Hurricane Delta begins to track towards the Louisiana coast, we do see low ocean heat potential here. And you can see that by all the blue shading. And essentially, this is an indication that the ocean is no longer in that really conducive state for significant intensification. In fact, if you look at actual sea surface temperatures along the northern half of the Gulf of Mexico near the Louisiana coast, they're actually lower than 27 degrees Celsius, which is not really favorable for convection to be present. So there are indications here that as Hurricane Delta begins to make its trip near the Louisiana coast, it could undergo some weakening, which is good news. So we're going to have to pay attention to essentially how the model's behaving as it tracks towards the Louisiana coast within 24 hours. If I bring up the latest HWAR forecast here, and I'm going to actually show the precipitation, the radar, and mean sea level pressure here. This is from Levi Cohen's Tropical Tidbits page. As we see the models predict this to re-intensify. This is in 27 hours, Thursday morning, right before right before daylight there in the central Gulf of Mexico. 950 millibar min central low pressure with a pretty concentric eye wall feature here. So this is where we expect that delta will become a major hurricane again. But as it moves and lifts further northward over those colder ocean waters now, we're seeing some changes in the predicted structure of this hurricane, where essentially that concentric circle, the eye feature, actually expands, and we see some possible erosion on the southern side of this hurricane, and it kind of stays that way as it tracks inland across the Louisiana coast. And while we might not expect this to be a Category 5 hurricane, right? It's not going to re-intensify because of that ocean water that's cold there. This is still going to be a very impactful hurricane strike for the Louisiana coast. There's going to be heavy rain, hurricane force winds, and due to the nature of the size of this cyclone here, we're going to see that storm surge, and the highest storm surge risk to be parts of the central bayous there for Louisiana. So this is going to be a pretty quick mover, though, right? As we watch this storm move inland, we don't see it stall out over the coast of Louisiana there, which is good news. Typically, when we have those stalling hurricanes, those are the ones that pretty much bring those historical rains, like 30 and 40 inches of rain like we saw for Harvey. This is not going to be that type of storm, but this is going to still have the wind, the heavy rain, and the storm surge. So this is more of like your classic hurricane strike here as it moves into the Louisiana coast. And then we do expect that to move inland and track in through western Mississippi and essentially degenerate into a tropical depression. So I'm expecting that we do get this this hurricane. It will start to move inland and out to the northeast later this weekend, and I'm hoping that we'll get some rain here in the northeast, where I'm in the Boston region, because I haven't seen rain in quite some time in the Boston region. So that could help with some of the drought that's going on in the northeast. Okay, guys. So I want to talk and take some questions in the chat here before I move on into some other topics. I appreciate you guys joining here. Rapid intensification happened yesterday. It was a Cat 4, 7 millibars per hour. Yep. I do see CJ is asking a question. CJ, thanks for joining the stream. Is there any chance that this hurricane tracks eastward? Well, actually, let me take out something that I've developed here and looking at the GFS Ensemble track forecast. Let's talk about the risk for where the actual track might go for Hurricane Delta as it makes landfall across the U.S. here. So this is 4 consecutive runs of the GFS Ensemble model. This is actually looking at today's run is the blue line here. And then as you get into like these lesser contoured or the less bold contours, the black lines, those are your older runs. So each run, you see the initialization happens a little bit further northwest with time. And then as you can see the most recent run here, your western flank of the possible envelope of where this core, the center of Delta might go, it actually has gone a little bit further eastward compared to older runs. And your easternmost core, your easternmost side of the cone here has gone from the Alabama, Mississippi area all the way to eastern Louisiana. So we're seeing a tightening of the cone as this hurricane approaches the U.S. And that's an indication that the models are starting to better resolve the track of this storm. We're starting to see that cone begin to shrink a little bit more. We're having a little bit more clarity on where the hurricane may track across. So it's looking very probable that Hurricane Delta will make landfall somewhere across the either very far eastern coast of Texas, anywhere from eastern coast of Texas all the way to central and eastern Louisiana coast, with the most likely track right in the western central part of the Louisiana coastline. So that's where we're seeing this model, as well as some other models, lock on for a possible landfall. I know the ECMF model is a bit further west, showing that maybe that Texas Louisiana border there, but I still think that the ECM is a little bit too far west with the storm, and we might start to see some adjustment eastward as as the models move forward in time. And I think we've seen this with some other storms earlier this year where the ECM was a little bit too far west. So if I show the ECMWF track, you can see how that track is compared to the GFS if I toggle between the two. And the ECM is a bit further west compared to the GFS, but I do think that that western central region will be the landfalling point for this hurricane. Um, so that covers some of the questions about the possible shift here. Um, I see some questions about Kelvin waves. We'll get to the tropics in a little while here. Hey, Kim, I see that you're back in the chat. I do appreciate you joining here. Any thoughts why the models weren't seeing the rapid intensification of Hurricane Delta at first? That's a great question. So why did the models miss the rapid intensification of Hurricane Delta? Well, there's a number of reasons why. Hey, our models haven't really gotten much better with intensity forecasts of hurricanes at all. They still struggle with hurricane intensity predictions. We're going to continue to struggle because the resolution of these models are still not at a point where we can resolve those internal core dynamics of hurricanes. They're very mesoscale, meaning very small. However, you think about track forecasts and how the models have gotten better. Yes, we've gained substantial improvement in predicting tracks of these hurricanes, and especially these cone predictions. We've seen the national hurricane cones as you go out further in lead times. They're much smaller now than what they used to be 5 to 10 years ago. And that's because our models are doing a better job of predicting where these storms might go. With regards to this particular hurricane, Hurricane Delta, the eye of Hurricane Delta was 4 nautical miles. That is not large enough for a model to resolve. And that's why we saw this model our numerical weather prediction models really struggle with the intensity of these storms. Anytime you get these very small systems, it's too small for these models to resolve, and that's causing problems in the intensity forecast. That being said, when I showed the HWRF model here, as it moves out over the central, I'm actually going to go back to the winds here because it's a little bit easier to see the eye of the wind here. So as the hurricane moves back over the Gulf of Mexico and towards the central part of the basin, we see the eye get much bigger. And this is an indication, this is probably now a resolution where the models can start to do a little bit better job than when the eye was 4 nautical miles. So I do expect the models start to do a bit better with the intensity forecast as this system tracks over the central Gulf of Mexico and begins to re-intensify. And that's because the inner dynamics, the core of this hurricane, is going to change compared to what it was prior to making landfall over the Yucatan Peninsula. Okay, guys. So another questions here from Ador. Thanks for joining, Ador. My last question: North Indian Ocean cyclone session is coming up. Would you like to tell us something? Would you like to tell us something on that, Professor? We would be very glad. Okay, so I will upload this video to the YouTube after the stream as I normally do, and I will get to more of a global scale of the tropics here once I finish up questions on this particular hurricane. So let me finish up reading into the chat here. Yesterday afternoon we had a Category 4 hurricane storm with no visible eye on satellite and no closed eye wall on the radar from the Cayman Island. How can that be? Okay, so anytime you get these very small eyes, it's going to likely be at it's too small for the infrared resolution or the satellites to pick up. And we have to kind of defer to things like radar. And even though we didn't have a closed eye wall on the radar, there's always the issue of like beams getting kind of degenerated as it kind of moves away from the radar. I think it was like 120 nautical miles away from the Grand Cayman Island radar that we picked up that on. So there's some like reflectivity issues that can arise there from the beams getting shot out from the radar from these storms. So that's why we have to rely on these recon planes for these very small cores, and the models the recon planes did a really good job of sampling this particular hurricane when it had such a small eye. If those recon planes never went out there, we would have never realized how strong this system was when it was tracking across that northwestern Caribbean Sea. So we have to rely on those recons. They're very important for us to diagnose these small hurricanes, to understand intensity, et cetera, because our ways that we monitor these cyclones, these very small hurricanes, very compact cores, we monitor these typically through radar and satellite. Sometimes these very small systems just kind of slip through the cracks and we miss these details. that hurricane hunters can give us. And that's why those hurricane hunter recon flights were so invaluable here when we were watching the storm rapidly intensify. Um, CJ, one last question here. I see you had it. Is there a new center reforming in the northern part of the storm? And that was going back to that hurricane, this satellite image here. Let me refresh this and kind of speed it up here. This is from the National Hurricane Center website, and you get a nice little mesoscale loop here. I'm speeding it up for things to kind of show up here. So this is where you're talking about. I'm expecting you're wondering, is this the recenter for the eye reforming here? And I definitely think it is. This is being really, the eye is now starting to emerge, and it's starting to see a ring of vigorous convection right in the northern coast of the Yucatan and off the coast there. So I do think this is an indication that the center is starting to reform off the Yucatan coast, and we should expect this now to be the main feature as the hurricane starts to move out and out over the warmer ocean waters of the Gulf of Mexico. And this is likely where we're going to start to see the reinvention or essentially the changing of dynamics of this particular hurricane from one was a very small core to a much larger hurricane now. And that now we'll expect this to continue, and we'll expect that the wind field of Hurricane Delta will also begin to expand as the storm essentially gets a bit more, it starts to intensify as it moves over that warmer waters. Okay, what influence did the remnants of Gamma have on Delta? So that's a good question. There was, we did see hurricane, we had Tropical Storm Gamma and now Hurricane Delta. Gamma moved through the Cancun region about 3 to 4 days ago, and now we saw Hurricane Delta move right through that region. There is a larger broad circulation. We call these tropical gyres. Philippe Poppin, if you ever guys want to follow an expert on these tropical gyres, Philippe does a really good job of covering these storms and these particular tropical features. And there was some interaction with these with the two systems, Gamma and as well as Delta. The remnants of Gamma is, I think, sinking somewhere south over central Mexico or Central America down there. And when we typically see that system dig further southwest here, it could produce more of a southerly flow across Delta here, and that is essentially allowing the storm to track more northerly here in the coming hours. And we're expecting that probably that Gamma influence to push essentially Delta further northern across the central Gulf of Mexico, and that's probably setting up the steering currents for a U.S. land strike. And actually, I didn't mention it, but when Delta does track across the Louisiana border, it's going to be our 10th U.S. land strike or tropical cyclone landfall. That's a record. That broke the record. I think it's 1916. Yeah, where we saw 9 storms landfall across the continental U.S. Right now, we're at 9 landfalling storms. This Delta is going to be our 10th landfalling storm. That'll be a record for the most landfalling systems or tropical cyclones in a given season, and that's going to be a 2020 new record, the year that keeps giving to us, guys. It's been crazy. Okay, so now I'm going to move off, and if we have some more basic meteorology questions here, and let me bring up some of my tropical diagnostics. I'm going to go to my internal website page here, and I'm going to bring up the new GFS 35-day ensemble forecast here, and we're going to start talking a little bit more nerdier about the deep tropics here, and talk about what I like to focus on for hurricane activity, and that's the Madden-Julian oscillation, and actually we'll get into more of the standing waves and the ENSO stuff. So this has been a seasonal base state in the tropics, the Atlantic hurricane season, that we've seen a very favorable pattern in the tropics set up for hurricanes in the Atlantic Basin or over the Atlantic Basin. This is why a lot of the seasonal forecasters were calling for such an active hurricane season this year. And that's because something called a standing wave, which is when the atmosphere essentially couples to ocean forcing and provides essentially this just overturning circulation, just stays there for many days, many months. And we saw that happen over the African Indian Ocean. And every time we have something like the Madden-Julian oscillation come through, we see an amplification of the standing wave over the, since we're in Africa here and the Indian Ocean down the little map here, if you bring your eyes up on this plot here, it's essentially looking at data all the way over Africa and the Indian Ocean. Time is going down on this y-axis, longitude's on your x-axis. And again, if you don't like looking at longitude numbers, there's a mini map below it. So let's say you want to look at South American data, you just bring your eyes up. This is all South American data. So we're looking at 200 millibar velocity potential anomalies in the shading. Wherever you see the purple and blues, you can think of that as rising air. Wherever you see the yellows and reds in the shading, you can think of that as sinking air. I'm showing contours on this plot, and that's MJO filtered velocity potential. Wherever you get the dash contours, that you can typically see the blue and purple shading under it. That is your active MJO branch. Essentially your active MJO state. And you can track these MJOs that goes many, they can make many circuits around the globe. And that's because these waves, MJOs and Kelvin waves, can be non-dispersive in nature, meaning they can just keep going round and round and round until friction breaks them up or they run into like a standing wave feature, etc. So back in July, we saw this active MJO pass the Indian Ocean. We had some hurricanes early, we had a burst in tropical cyclone. I think there were some hurricanes back in early July. I'm sorry, the front half or into the latter half of July into early August. And then as the MJO moved across the Pacific Basin back in mid-August, we saw the hurricane activity kind of quiet down a little bit. And then the MJO came back around again in mid-August and really amplified the African Indian Ocean standing wave. And that resulted in a burst of Atlantic hurricane activity. We saw a ton of storms develop. And then once that MJO began to move back across the Pacific Basin, or kind of actually started to decay in all honesty, we saw a little bit of a lull in activity late in September. But then obviously as we're back now into early October, the first week of October, we saw 2 new storms develop. And, there's been some weird things going on here where we didn't really see this MJO continue eastward and continue on its merry way. It actually stopped and slowed down over the eastern Indian Ocean maritime continent. You can actually see the blue and purple shading really kind of slow down there and just kind of stick in this area. And we're starting to see this slow eastward drift. And I think what's happening here is we're seeing the atmosphere readjust into more of a La Nina forcing pattern. I think what's happening here is our standing wave is actually shifting eastward to the maritime continent. And we expect this to happen usually in fall and winter as we're in a La Nina pattern. And I think that's why we're starting to see this interference in the velocity potential pattern. But I do want to note and point out here that if you look in the forecast in the GFS ensembles, we are starting to see the blue shading come back late in October into the front half of early November, or actually the midpoint of November. This is another state in the tropics that suggests we could see another period that's conducive for future developing tropical cyclones. Now, if you look at the models after Delta, we're not really seeing a whole lot in the models for new storms to develop. But I don't think that that means the end of the season. I think with what these models are showing, in the week 3 time frame, is that we're seeing a transition in the tropics where we could start to see another, conducive state for developing hurricanes over the Western Caribbean and Gulf of Mexico. And that conducive state looks to kind of turn on sometime in the final week or so of October and continue through the front half of November as that velocity potential signature really kind of highlights that South America, Western Caribbean signature, and that really indicates that we could see another tropical gyre come back. And whenever we see these Central American gyres redevelop, that's where we're going to have to pay attention for the Western Caribbean and Gulf of Mexico for future storms. So after Delta's going to, the landfall is likely going to happen here on Friday. So the next 48 to 72 hours, we're going to watch that storm hit the Louisiana coast here and strike that area. There's probably going to be another 1 or 2 storms coming here late October into the front half of November, and that's I think this is going to be like our last hurrah for the hurricane season, because after this early November pattern breaks down, as we get into like mid-November now, the hurricane season is going to end, and it's going to end at what was such a remarkable pace here. In 2020, and this is going to be this 2020 will likely go down in the record books as thinking similar to 2005, which was a remarkable season as well. And the season did not disappoint for some of the more active hurricane calls. So focusing now as we get into that November timeframe, let's take a look at the standing wave forcing plot that I have created here. You can do some low pass filtering and look at how the Indian Ocean standing wave has evolved here. We're essentially looking at that velocity potential pattern, but we're filtering it at lower frequencies. So we're trying to find out where these standing waves are in the tropics. And wherever you see the blue shading, it's essentially the atmosphere is just rising continuously over many days and many months. And we're filtering out things like MJOs. We're filtering out things like Kelvin waves. We only want to focus on the very low frequency forcing modes. And an example here is back last winter. This is January, February earlier this year. Well, you see that there was blue shading over the Central Pacific. This was like your El Nino or your central El Nino, which is known as Motoki. This is your central El Nino forcing. Back in June, we saw that forcing turn off. We're looking right over the Central Pacific Ocean here. So you bring your eyes up here. You can see how this was a blue to orange type of evolution as you bring your eyes downward across that plot. And this is essentially your atmosphere coupling to La Nina. It's essentially saying, hey, we don't want to rise. Air doesn't want to rise over the Central Eastern Pacific anymore. It wants to sink. And this was a big culprit for why we thought the Atlantic hurricane season was going to be more favorable. When you have sinking air over the Pacific Basin, that allows us to have less shear over the tropical Atlantic Basin. However, we saw the blue shading. This is a standing wave where air is continuously rising, just pretty much persist over the African Indian Ocean since last fall. It set up last fall and stayed there all the way through hurricane season. This is your African Indian Ocean standing wave. And now the models are showing that the core of that standing wave is central Indian Ocean. And you can start to see the black lines start to slope here from towards the east with time. You can kind of see the slope there. And that's essentially your standing wave is now drifting more towards the maritime continent. So this is your atmosphere starting to move into more of a state that's conducive consistent, with La Nina. What does this mean for the Indian Ocean hurricanes or cyclone season, right? Well, when you have this standing wave feature set up, it's typically a very favorable state for Indian Ocean cyclones. So in addition to a very good state for Atlantic hurricane season, your Indian Ocean cyclone season is probably going to be more active compared to normal with this particular pattern. And we typically see the seasonal adjustment of the intertropical convergence zone, the ITCZ, which is where these hurricanes typically spin out when you get over the Indian Ocean. That's going to move back towards the equator here in the next couple months. And as it does so, when we get into this favorable state, what we're seeing here, we typically could see cyclones, we call tropical cyclones over the Indian Basin cyclones. We could see twins. We could see one over the southern hemisphere, one over the northern hemisphere, and the timing of these cyclones will be when we have MJO passages. So if we do get this early November MJO passage across the South America Atlantic Basin, I expect that to continue onward towards the east, and it could potentially move back over the Indian Ocean probably around the second half of November. And that's where we could start to see some Indian Ocean cyclones spin out. So that hopefully covers some of the cyclone season questions that I had in the chat earlier. And if there are any other questions on some nerdy tropical, deep advanced tropical, meteorology concepts, please feel free to ask in the chat. But this by far was one of the biggest signals for seasonal forecasters. This Indian Ocean African standing wave and the turn off of the Central Pacific forcing to more of a subsidence zone. This was the big signature for hurricane seasonal forecasters to call for such an active hurricane season. And I think as we look on to future years, when we're trying to make these calls for hurricane forecasts at a seasonal level, we need to pay attention to these. We need to start to pay attention to these types of diagnostics, these low frequency filtered velocity potential diagnostics, because they do such a great job of identifying where the standing waves are in the tropics. These are sea surface temperature anomalies compared to the standard 30-year climate, the 1981-2010 climate. And we see a large fetch of colder than normal ocean waters from the coast of South America all the way to the date line. And this is your classic La Nina type pattern here in the ocean. If we actually take a look at how ocean waters are in the Western Pacific, you see that the Western ocean temperature anomalies are very warm. And as our standing wave starts to adjust over the Western Pacific here, this is probably where we're going to see most of the main forcing this winter. It's going to be probably one of those more canonical La Nina type driven winters. We typically see a lot more North Pacific Ridge patterns in those types of winters. And when we have those North Pacific Ridge patterns in winter, we typically see a pretty significant cold pocket set up over Western Central Canada. And that sets up this pattern can be very conducive for Arctic air intrusions across the U.S. in wintertime. So last winter, we had a very quiet winter with regards to snow and cold ocean water, cold temperatures. It's very warm. It does look like this winter will be a bit colder and more volatile as you look at the U.S. temperature pattern. And hey, apologize if you guys got kicked out of the stream here. It looks like my OBS software is starting to show some hiccups in the stream, so I do apologize for that. So I do see there's a question about Westpac activity has been unusually quiet this year. With ocean temperatures this warm, right? Why has the West Pacific typhoon season been a bust? Well, that kind of ties into why I think staring at these standing wave diagnostics are so important. If anyone is a future meteorologist and does plan on going to school and really want to understand seasonal predictions of hurricanes or tropical cyclones in any basin, guys, I'm telling you, take a look and start to build diagnostics off of these low pass filtered velocity potential anomalies. Because when you had an Indian Ocean standing wave set up, like we've had all year, what this means is your rising air is most favorable across the African Western Indian Ocean, right where your blue shading is kind of focused. If you look at the Western Pacific, we actually didn't really see much in the sense of rising air. And actually, if I could actually go to a map form of this, because those are the Hofmüller diagrams. Let's take a map form. Take a look at what happened over the Western Pacific this season. There's actually subsidence over the Western Pacific in response to the Western Indian Ocean standing wave that's set up. And that subsidence, if you're in between this positive VP filtered anomaly and the negative, if you're in between this couplet here, this is not a favorable area for tropical cyclones to form. There's actually a lot of shear in this region. A lot of dry air can kind of stick in here. You can think about essentially when you're east of this purple contour here, you can think of that as upper level winds are essentially westerly along the equator, and that essentially will result in a westerly wind duct to open up along the equator, and that can essentially bring down extratropical waves towards the tropical, and that can interfere with developing storms. So the Westpac was doomed this year because of this low frequency state, and that's why we haven't seen a ton of Westpac storms this year. And this is a really nice example of not looking at ocean temperatures anomalies, but in fact looking at atmospheric diagnostics to conduce the base state, and that can really tell us a lot more information on why a particular season could be more or less active in a particular part of the world. Okay, let's take a quick change over to ACE, and this is a nice product put out by the Colorado State University, and they track a ton of diagnostics, the number of storms, the number of named storm days, hurricane days, major hurricane days, etc. And they also look at this thing called accumulated cyclone energy, or ACE. And if we bring our eyes down to the Atlantic Hurricane ACE chart, the black line is our climatology. That's our normal line. And the blue line is what we've seen 2020 to date. And since, what is this here? Since May, ACE has been above normal the entire time. We've been faster to get ACE, build up our ACE totals all season. It did get closer to normal levels back in early September, but with the recent burst of activity late September, we've seen ACE values continue to climb here, and we are currently, this is 2-day lag here, we're currently at 112 ACE values October 5th, and normal is 86, so you can see how we are well above normal for the year with regards to ACE. Climatologically speaking here, we typically peak out around 105.6 ACE values through December 31st here, and we achieved 105.6 back in early October. We essentially this week have beaten the seasonal diagnostic or the seasonal state of ACE values. And with regards to Hurricane Delta coming up here, it's going to re-intensify, and possibly another burst of hurricanes, either one or two more hurricanes late in October or into the first or second week of November. I expect ACE to continue to rise here through the end of the season. So I think ACE is going to continue to rise and be a rememberable year. Excuse me for stuttering there on that. So let me get back here with the end of the stream share and just kind of chat with you guys. To sum up here, guys, we've seen essentially Hurricane Delta make landfall across the Yucatan. It's currently tracking across the northern Yucatan Peninsula right now. It's actually probably emerging off the coast later in the next few hours here. We're starting to see indications of the center reunite with convection. We're starting to see that eye wall begin to become more defined on satellite imagery. And this could be now a point in time where we start to see Hurricane Delta begin to re-intensify. And the National Hurricane Center does suggest that Hurricane Delta will re-intensify into a major hurricane, Category 3 hurricane with 120 mile per hour sustained winds. That being said, we have issues with intensity forecasts. We have these issues all the time. That's because the models struggle with really resolving the inner core dynamics of hurricanes. So we're going to have to keep an eye on this storm as it moves across the central part of the Gulf of Mexico basin and tracks towards the Louisiana coast. We have a good idea that Hurricane Delta will make landfall across the either western or central part of Louisiana, which luckily this is not really a highly populated area. But that being said, when the storm begins to grow in size as the eye diameter expands here, the wind field is also going to get bigger. So we are going to have to deal with storm surge concerns from eastern Texas, Galveston Bay region, all the way through the New Orleans region. Right now, the earliest predictions of storm surge that I'm seeing, the max peak is around 7 to 11 feet, and that's that's predominantly in the central Louisiana coastline region, where there's pretty much just animals. But we are going to have to worry about river flooding. We're talking about some of those rivers the one that I really butchered, and then obviously the Mississippi River, which runs through Baton Rouge. We're gonna have to keep an eye on that river for possible river flooding here, because there is some chance here as the winds are more southerly, southeasterly. We're going to see water get pushed up the Mississippi River bed, and that could potentially cause some riverbank flooding scenarios for some of those coastline regions. So, or some of the regions that are laying in those riverbanks. We are dealing with a fairly quick progressing hurricane, so I don't think the storm is going to stall out along the coast, and that's good for the sense that we probably aren't going to see those historical rains anywhere. I do think that there could be some 12-inch mark rains in some of the areas where the actual center tracks through, but we're not thinking, at this point anywhere, we're not going to see 20 to 30 plus inch rain totals with this storm, and that's something that is good news. But we will have to deal with hurricane force winds, and we will likely see those winds be pretty stout as it moves in through western Mississippi as well. And it will, as the storm moves inland into the Tennessee Valley and into the Ohio Valley later Saturday into Sunday, we are expecting the winds to continuously decline. That's because land has friction, and the friction can really interrupt the dynamics of a tropical cyclone. And we expect those storms to slowly wind down in wind speeds, but rain will be the biggest threat as it moves inland. One other thing that I want to talk about, there still is some uncertainty with the intensity of the hurricane as it moves across the Louisiana coastline, and that's because the ocean temperatures are colder as you go up into the northern half of the Gulf of Mexico. And that could potentially begin to weaken the storm as it moves onshore. But since this is going to be quite a large storm, it might take a while now for the storm to wind down. So while there could be negative influence by the ocean on the storm intensity, um, the fact that the eye is going to be bigger, it suggests that the actual hurricane core could be more stable. So I don't want you to be not on guard here if you're on Louisiana, because a big wind field, it's going to take the storm to slowly wind down. Even though the ocean waters are cold up there, we don't expect this storm to be moving there slowly, right? So it's not going to be sticking over these colder waters for a long period of time. So in fact, that faster progression of the storm is good in the sense that it's not going to have these historical rains, but it's bad in the sense that it's going to be over those colder waters for a short period of time. So the storm could potentially hold together as it moves into the Louisiana coast. That's something that we're going to have to pay attention to here, and it's critical to over the next 24 hours to see how the storm regains intensity as it moves over the central Gulf of Mexico. And I will continue to provide updates on Twitter, but I do want to say again, for the guys who have rejoined the stream, apologies for the stream kind of disconnecting there. If you guys are paying attention to the storm, you're in the Louisiana or Mississippi region, and you want to, your life or property is at threat, please follow the National Hurricane Center for up-to-date information, as well as the Weather Channel iPhone or Android app or weather.com. We do provide information out there to prepare you with up-to-date information on the storm, because we want to make sure you guys are safe during these events. So thanks, guys, for joining the stream. I appreciate you guys, every week. Apologies I missed last week here. I had some personal things going on, but I'm back at it here, and I do expect to be returning next week. We'll kind of sum up what happened here with Hurricane Delta, and we will talk about any future prospects that I'm looking at in the models. All right, guys, that's it for me. I hope everyone has a good rest of your Wednesday. It's time to get back to work, and be safe there, anyone who's in the path of this potentially dangerous hurricane. Thanks, guys. Take care.